Thank you for having me here. I'm really looking forward to the next 40 minutes, all about TypeScript. And yes, I do a lot on the Microsoft stack. I mentioned it in my first talk too, but this talk is absolutely not about Microsoft. TypeScript is fully open source. TypeScript is running on every platform where Node.js can run. TypeScript is written in JavaScript or TypeScript, and TypeScript is entirely open. So all the things that I showed today, I have it here on my Windows 10 machine, but you can do everything that I'm going to show you today on your Linux or Mac OS box. Everything relies on Node, and even the editor that I'm going to use, Visual Studio, I'm going to use Visual Studio Code, which is platform independent, free, open source, and also written in TypeScript, HTML, and CSS. Okay, so this talk will not be with slides. I don't have any slides with me. So we're going to have 40 minutes of code, doing a lot of writing code, looking at code, deploying code, running code. I'm not going to show any slides. Feel free to interrupt me. Feel free to ask any questions if I screw something up or whatever. We are using TypeScript. We have been using TypeScript for quite a while. Approximately 1.5 years. It was version 1 of TypeScript when I saw it, and I immediately fell in love with it. And I want to start up by showing you why. This is the TypeScript playground. TypeScript lives in the web on the website typescriptlang.org. And what I can do here now on the left-hand side, I can enter some TypeScript code. Let me zoom in a bit. I can enter some TypeScript code, and on the right-hand side we see the JavaScript code. And the reason why I loved TypeScript from the first day on is the following. I don't want to write the code on the right hand. Essentially, I can't write the code on the right-hand side. I know it, I can read it, but I don't want to write it. I want to write the code on the left-hand side. I'm from a typed languages world. I write most of my code in C#. Previously, I did also C++ and things like that. So I'm used to types. It's nice to have some, let's say, possibilities to throw away types. That's possible in C# too. You just write dynamic and you get runtime types, of course. But in many cases, types are nice. And essentially, that is what TypeScript is all about. It lets me add types if I need them. But there is one common misunderstanding with TypeScript. TypeScript does not force you to have types. If you don't want types, if you don't want types for a certain part in your application, if it just stands in your way, you don't have to use types. You can always use the type any, which essentially says, hey, TypeScript, do it in runtime, rely on the typing of JavaScript, and don't bore me with any kind of typing, type checking, or things like that. So what TypeScript is, at its core, it's an extension to JavaScript. It's a superset of JavaScript. And it's, if you want, Microsoft's work of proposing new things to the ECMAScript standard. So when we started to work with TypeScript 1.5 years ago or a little bit more, we were immediately able to use modules. We could write classes. We could use inheritance. We could use interfaces and things like that. And parts of these things are now in the newest ECMAScript standard. We can now, with TypeScript, use async await, a great feature in this language. If you ask me, if you do a bit of Node.js development, you know what I mean. I mean, async is nice, but async await is really a nice thing to program with. We can run it today. It works perfectly fine, but it will be in the next standard of the ECMAScript language. So TypeScript is a bit of writing ECMAScript code that will be possible in the future, but using it today. So it's kind of transpiler if you want. You can also use things like Babel and things like that, but TypeScript goes a nice step further, and I will show you how this works. So, as I said, TypeScript is written in JavaScript, so you can run it on the client, you can run it on the server, and things like that. Last thing before we really go into code, when we decided to use TypeScript 1.5 years ago, there have been people who were asking us if we were really serious. I mean, there was this CoffeeScript stuff, and we had this AdScript stuff from Google, and we had this Dart stuff from Google, and nobody really believed in TypeScript. However, we tried it, we loved it, and we decided to use it. And we were very, very happy when Google announced that they dropped their ad script and they rewrite their entire TypeScript Angular 2 code and develop Angular 2 in TypeScript. We were really happy when we heard that because, yeah, we bet the farm on TypeScript and it worked. Yeah, that's really nice. So today we have one of the largest frameworks in the JavaScript client-side world, which is Angular 2, and it's entirely written in TypeScript, and that's a very good news for us. Okay, so what is TypeScript all about? Let's stay in this TypeScript playground a bit, and yeah, let's see. First, let's write some very simple code, something like this. Okay, on the left-hand side TypeScript, on the right-hand side JavaScript, no difference. Okay, no difference. I dot, and now is the real difference. The first time we have difference. TypeScript types are super important for editors, for powerful editors, because TypeScript typing enables the editor to give you much more intelligent IntelliSense on the one hand side and refactoring functions. That's the important thing. If you have a large JavaScript project and somewhere in this JavaScript project you have this property which is called description and you want to rename it, and you do a rename across all your JavaScript files, renaming all descriptions to something else, you are probably going to screw up your code. If you have types, then the IDE can understand where you really reference this very property, which is called description, and can offer you very intelligent refactoring possibilities, for instance. It can do type checking, of course, this will be done by the compiler, but in this case I'm just getting IntelliSense. If I would do something else, if I would do something like this, and I would say I dot, and you see I get different IntelliSense. Here I'm using the browser, I'm just writing code in the browser, and this proves that TypeScript runs perfectly fine in the browser. So if you want, you can do TypeScript compiling in the browser. Of course, that's just for experimental purposes, not for production purposes, but it works. What happens if I do something like this? Well, on the left-hand side, I get an error. I get an error that number is not assignable to type string. But still, on the right-hand side, you see that JavaScript is generated. So this is a very special kind of error. On the left-hand side, TypeScript has an error. Yes, that's true. But I can decide as a developer, I can ask the TypeScript compiler to spit out JavaScript code, even if it finds such minor errors. So if you have JavaScript code and you want to turn it into TypeScript, rename it from JavaScript from JS to TS, and well, in many cases it will just work. Maybe you get things like that, which is not very beautiful JavaScript, or maybe you want to write the JavaScript code this way. Well, the TypeScript compiler can handle this. Of course, in our case, I want to remove this. Well, let's not remove this. Let's opt out from typing. I can just say, hey, I is any, and from there on, TypeScript will not do any type checking anymore, and the code is perfectly fine again. So that's a little bit intro into typings. Now, let's do something else. Let's create a class. Something like this. Let's create a constructor, and let's put in a first name of type string. And yeah, we can do something like that. Public. This public here says that first name should be a public property on the person class, and the constructor should automatically copy the value which is passed to the constructor into the local property. So what I can do now is I can say var p equals new person, and I can say max, and now I can say p dot, and I get first name because I wrote public. See? And here you see the nice thing with IntelliSense and things like that. And that's the second nice feature. I already mentioned it in the beginning of my talk. On the right-hand side, you see the code that TypeScript generates. So TypeScript adheres to the usual patterns for classes, modules, and so on. So some of you may now wonder and say, well, that's okay for old ECMAScript standards, but what about ECMAScript 6? Well, in fact, the TypeScript compiler, with the TypeScript compiler, you can decide which kind of ECMAScript you want to produce. You can tell the TypeScript compiler, hey, TypeScript, please generate ECMAScript 6. It's still called ECMAScript 6 in the TypeScript compiler, and it will spit out a class. it will not use the complex class pattern that you see on the right-hand side. So it's up to you. You can use classes if you have an old browser which is not able to understand class. You spit out ECMAScript 5, for instance, or even ECMAScript 3, and let TypeScript do the heavy lifting of rewriting the code so that it is compatible with the appropriate ECMAScript standard. That's possible for most language constructs, but not for all. For instance, async await today is only supported in TypeScript with ECMAScript 6, but Microsoft is currently working on downporting async await to ECMAScript 5. So you will be able to write async await and compile it to ECMAScript 6 if you have a host, Node.js, that understands async await, and compile it down to ECMAScript 5 if your code runs, for instance, in the browser. That's a very important thing. So, next one. We not only have modules and classes, and of course we have things like functions. Let's do something like this. Public first name up, something like this. Let's call it get. And do return this dot first name. You see IntelliSense, of course, to uppercase. Okay, and if I say p dot, I get the method, and I say, you see, in this case, TypeScript determines the type of get first name upper by looking at the return statement. So I didn't specify here explicitly a type. I can if I want to, but I don't need to. I can remove that one. TypeScript does its very best to find out the type. It's called implicit typing, to find out the type if you don't explicitly specify it. Okay? Of course, you can also define things like something like I number goes to string. That's a kind of lambda. Let's call it callback. Something like this. Yes, that should work. So what I specified here is I want as a parameter a reference to a function which gets I, a number, as a parameter and will return string. So in that case, I can say callback, and I also get, as you can see here, IntelliSense for lambda expressions and delegate types. So if you work in used versions of Java, I've heard so, I'm not a Java expert. I come from C# and I live with lambda expressions for quite a while now, and this is very, very beautiful. It's the way I write C# code for years now. Okay. Next thing, interfaces. We also have interfaces. iPerson. And let's do something like first name, string, and last name, string. And then let's say that person implements iPerson. So first we get an error. Why do we get an error? Because person does not contain a last name property. So with that interesting thing, we get some intelligence based on types. So let's say public last name string, and with that the error disappears. But take a look at the right hand side and look at what's happening with the interface. It's not there anymore, it's gone. That's an important point because an interface is just type information and interface just disappear. They are not there in JavaScript. So interfaces are just used for IntelliSense and compile time type checking. That's what interfaces are for. But now comes the interesting stuff. Let's do the following. Let's say this is an iPerson. Person. And say p equals. That works perfectly fine. We have to remove that one. That works perfectly fine. Now let's remove the implements iPerson as one. And, we don't get any error. We don't get an error, although we say p is iPerson and we assign a person object, which does not implement iPerson. But in fact, it does. It does it by having first name and last name. It's called structural subtyping, what's happening here, or some call it duck typing. It quacks and it looks like a duck, so let's call it a duck. It's something like this. It has a first name, it quacks. It has a last name, it looks like a duck, so let's call it a duck. If I do something like this and say quack, quack, and I ask you, what am I? You will say, you are a duck, but biologically, I'm not a duck. I promise you, definitely. But in that case, person is iPerson. You get the idea. This is a super important important concept of TypeScript, and it enables a huge field of possibilities. I want to show you something. Now I can say p equals, and here I'm using not a class, but an anonymous JavaScript object. And I get IntelliSense for an anonymous JavaScript object just because of the type information that comes from the interface. So that's nice for IntelliSense purposes. Tom. Turbo. That's nice, but still, if I mistype something, I get an error. So the system helps me a lot in preventing mistakes, type mistakes, for instance. The other thing is, imagine that this anonymous JavaScript object came from the server via a RESTful web API request. I just get a JavaScript object. I don't need to take this stuff and refill it to any kind of class so I can call it an iPerson. I just take the JavaScript, the JSON thing that came through the RESTful web API and call it an iPerson. And JavaScript and TypeScript will be perfectly fine with that and will offer me IntelliSense. And that works, for instance, for arrays too. I can say pArray is an iPerson array. And then I can say pArray dot push, and now I get IntelliSense with iPerson. So if I now specify here an anonymous object, I get IntelliSense based on the type of the array. And that's possible for generics. You can create generic methods. You can create generic classes. You can use it in inheritance and all this stuff. That's really powerful. We really love this concept. And this concept brings me to the next step. I want now to leave the playground and go to real code. Because the next thing that we have to ask ourselves is, now we have this TypeScript, but what if we want to use, let's say, jQuery? jQuery is not written in TypeScript, and I doubt that anybody will sit down and rewrite jQuery entirely in TypeScript. Maybe it will happen, but today it's not there. So what now? The answer are interfaces. I want to show you how this works. There is this awesome GitHub repository, and let's look up jQuery here. I want to have it something down here, and here is jQuery. And it happens that there is a GitHub repository where people and organizations, also Microsoft, sat down and created interfaces for all the popular JavaScript libraries. Because at the end, the dollar object of jQuery can be described in an interface. And it's perfectly fine because of structural subtyping. It's fine. We can, for instance, here at the bottom line here, we can declare a variable called $, and it is typed jQuery static. And if I look for jQuery static and go up there to the first appearance, no, to the second appearance of jQuery static, we see that jQuery static is nothing than an interface. So it is something like a header file for C++. Get the idea? So we have some, only a few, libraries described with these type definitions. And you see, there are a few libraries which have been described in TypeScript up to now. We stop for nobody. We can go up there, and you will see that currently we have 1,569 libraries described with TypeScript type definitions. So that's an important point. And what about the new stuff? With Angular 2, for instance? They will deliver the DTS file, the TypeScript type definitions, out of the box. We don't need this stuff anymore. They deliver it in their NPM package. So if you npm install Angular 2, you will get the DTS file for TypeScript together with their JavaScript libraries so that you can start programming with it immediately. That's an important point. And the key that enables all this is this structural subtyping of interfaces and external declarations. So let's make use of this. What I created here is essentially an empty directory here. I have it here in my command prompt, and I'm going to use Visual Studio Code. Who of you is familiar with Visual Studio Code? Okay, some of you. Visual Studio Code is the newest part of the Visual Studio product line, and it has some major differences from the large brother, which is called Visual Studio. First, it is platform independent. It runs on Mac, on Linux, and on Windows. Second, it is completely open source. And third, and that's important, it's entirely written in TypeScript, HTML, and CSS. So what you see here is an Electron Atom shell around HTML, CSS, and JavaScript. That's important because we can run exactly the same IDE if you want directly in the browser. So you can use your Chrome or your Safari and spin up Azure and edit your TypeScript code directly in your browser, and you will have the same experience that I'm going to show you here. So that's an important thing. I really like Visual Studio Code. It's fast, it's small, it's platform independent, and it works perfectly fine for C#, for PHP, for Go, for JavaScript, TypeScript, and many, many other languages. Okay, well, do you know if they support Java already? I don't know. I don't think so. But it might come. Well, let's see. I really don't care, but yeah. So let's write a bit of code. Let's first concentrate on the back end. So let's write, let's call it server.ts. Let's write a bit of Node.js code. Okay. So for the Node.js code, we need some libraries or something like this. So we need to get some libraries. And which libraries do we need? Okay. Let's do an npm init. Okay. Fine with that, fine with that, fine with that, fine with that, fine with that. Okay. Yes. The first thing that I do is I'm writing TypeScript code. So the first thing that I do is I have to get the compiler. So let's do an npm install TypeScript safedef, because it's a development dependency. You see, you get the idea? I pick the compiler with the appropriate version and write it in my dependency file. So I have the compiler in my directory. I can go to Node modules, I can go to TypeScript, and I can go to bin. And I have my TSC here. Let's run the compiler, TSC like TypeScript compiler, node modules, TypeScript, bin, TSC, and you get the TypeScript compiler. Voila. So first, we have installed the TypeScript compiler. That's fine. Next thing, we need some additional modules, npm install express. And what else do we need? The body parser. And what else do we need? The course. Just some Node.js modules. It's not that important. It's important to remember that we're using the Express framework, some existing JavaScript frameworks. Okay, looks good. Now we have a package.json file, and I can also go here and take a look at the JSON file. You see the TypeScript thing here, and so on. So here I have my server TS, my TypeScript, and I will say console.log hello world. Okay, this is obviously correct Node.js code, but it's TypeScript because it's in the TS file. Now we have to compile this TS file into JS. No problem. I'm just going to call the compiler that we just installed, and I'm going to compile app.ts. Oh, sorry, it's server.ts. Thank you very much. So now we have a server.js. It looks exactly the same, but now we can compile. Isn't that great? Well, not really. In reality, we don't just have one file. So in reality, we have more, and therefore we can say tsc init, --init. And what we get here is another nice JSON config file. And that's important. If you want to configure the TypeScript compiler, you do that in such a JSON file. It's called tsconfig.json. And for instance here, I can tell the system, hey, I want ES56 whatever. Do you recognize here nice IntelliSense inside the JavaScript file in Visual Studio Code? Really nice thing. Let's generate ES5. No implicit array. Any tells the compiler if it accepts an implicit type of any. Let's say false, that's okay. We don't need an output directory. We don't need a root directory. We don't need source maps for the moment. And the only thing that I want to add here is files. And let's say server.ts. And then I can just say TSC, and it will compile. So let's erase server.js to prove the point. You see, there is no server.js. Let's call the compiler again. Okay, and now we have a server.js, so the TypeScript compiler now fetches all the settings from this tsconfig file. And by having such a tsconfig file, I can do something else, and that's important. I can just say tsc watch. And now, exactly. And now the TypeScript compiler sits in the background, just like Gulp would do with the watch task. It sits in the background, it recognizes the tsconfig file and watches for changes. So if I go to here, Visual Studio Code, and do something like this and save it, and go here, file change detected, it did a compile, and everything's fine. So of course you can stick to Gulp or Grunt or whatever you have. There are Gulp tasks, there are Grunt tasks that use the TypeScript compiler in the background. It's easy to set up. Take a look at my GitHub repository. You will find tons of samples there with Node.js, with client-side stuff, and so on. It really works nicely with all these build automation tools that you are probably used to if you are a web developer. But of course, that's not all. Let's run this guy here and start a new developer command prompt and go to this directory. Yeah. Okay. The next thing is I now want to use the Express framework. So I want to, in Node.js, I want to do something like import Express equals to require Express. Now, of course, I get an error because cannot find the module Express. I installed Express, but with npm. So the JavaScript files are already there, but TypeScript doesn't know about it because it's just Express.js. It's not TS. It's exactly the same on the client, by the way. I will show you that in a few minutes. So with Angular, with jQuery, TypeScript doesn't know about it. So we have to get these TypeScript type definitions from GitHub. Can you remember what we had before in the GitHub repository? And for that, there is another tool. Of course, there is always a tool with JavaScript. And this tool is called TSD, TypeScript Definitions. TSD is, of course, a Node module. Of course, what else? And what I can say here, I can say TSD query express. I can ask TSD, hey, do you have metadata? Do you have a DTS file for the Express framework? Let's see. Yeah, there is one. So we can install it. TSD install, and we can also say --save. And this --save does exactly the same as you are used to from npm, for instance. So we got another what? Config file, of course. Another JSON file. Yeah, we got another JSON file which is called tsd.json, and this tsd.json now has the express.dts file, and it imported all the typings here in a folder which is called typings. You have the Express framework, and the Express framework needs the Surf static framework and the MIME framework and the Node base class library if you want like that, if you want it like that. And it also creates a DTS file, as you can see it here, which includes all the DTS files that we just before imported. So what I can now tell my application here, server.ts, I can say reference path typings tsd.d.ts, and that's it. And now, can you see? Error is gone. That's exactly what I wanted to have. And now I can say var app equals express, and now I get IntelliSense. I, for instance, can say app dot, and let's say app.use, for instance, and you see, I get IntelliSense. I get all the documentation that you could otherwise look up on the website of the Express framework. I think you get the idea. Now I can do the same with Course, I can do the same with Body Parser, I can do the same with Needle, I can do the same with Async, I can do the same with all the public and widely spread Node.js frameworks. Yeah? Import the DTS files, launch the compiler, everything's fine. If I screw something up, of course, if I pass here rubbish, for instance, like something like this, of course I will get an error, and with Visual Studio Code I immediately get this error directly during edit time. If I would save this, I could also run the compiler, it would give me an error and things like that. You don't need to use Visual Studio Code. You can use WebStorm, you can use Sublime, you can use the full edition of Visual Studio, you can use your favorite editor. All these editors are today supporting TypeScript. Okay. I have prepared the ready-made server file because otherwise I wouldn't be able to show you, here we are, to show you some client-side stuff too. And what do we have to do? TSD install, what is missing? Body parser, save. That gets us the TSD files for body parser. And finally, we need to install course. If we close that guy and open it again, and I don't need to open it. Yeah, it already compiled. Everything's fine. So now we have a server.js here. Visual Studio Code will need a few moments until it recognizes the DTS files. So this is a very, very simple REST API. I'm able to ask for some customers, as you can see here. And you know what? Let's add one sample customer. Let's give it the ID. Do you see that I get this nice IntelliSense first name? That's all because here I created an interface iCustomer, and I'm telling it that I called it repository. I'm simulating some kind of data storage, and I'm just telling the system I have an iCustomer array, and let's call him foo, and last name, let's say bar, for instance. Okay, that's fine. So you see, the compiler already picked it up, and we can now run this guy, server.js, okay, and use our localhost 1337/customers, let's see, and here we are, foo bar. That's exactly what I wanted to have. I now have a web API written with Node.js in TypeScript with typings, with interfaces, or with IntelliSense for popular Node.js frameworks, exactly what I wanted to have. I have the TypeScript compiler locally installed, so I can use two projects, both of them using their separate version of the TypeScript compiler. If the one project is not already ready to use 1.7, they can stick to 1.5 if they want. It really is I think it plays nice with the rest of the web development part. So this part is now nice. So let's close it with this last 7 minutes or so with some client-side development. And I have prepared the client-side development, and I will just focus on the important parts which are specific to TypeScript. I'm not going to mention all the basic AngularJS stuff, but I want to show you how I can use, for instance, the client-side world with AngularJS. I'm going to use Angular 1 here because it's a little bit more interesting, because Angular 2 is already written in TypeScript, and of course that works. That works perfectly fine. So I now created here the client-side AngularJS code, and we see some important things. First one, we can use, now that we have Node.js in the background and Angular on the client side, we can share code. We can share interfaces, and with that we get something very important. We get here type-safe RESTful web APIs. That's an important thing, because now I have my web API, I get my customers, but I want to show you what I can do here. First we have to clear the error with the Angular stuff here. It says, hey, ng is not known. Ng is the module that TypeScript is using for Angular, and the only thing that I have to do is TSD query Angular. Let's see if there are some metadata for Angular. Maybe somebody has written TypeScript definition for the Angular framework. Yes, we are lucky. What else? Install, save. We got jQuery too, because Angular 1.x uses jQuery in some areas. So let's go here. fetch this guy here. I have to restart it. No problem. So now it should, yeah, now it's there, and you see dot, and I get all the nice interfaces of all the Angular stuff. Are you familiar with Angular? Well, some of you will be. So you might know the $HTTP service, and as you can see here, we have an interface that is describing the $HTTP service, so I don't have to know what $HTTP is all about. I can just hit dot and I get IntelliSense just as I would like to have it. I can hit F12, for instance, go to definition, and I'm directly in my DTS file, and I can take a look at the documentation, at the different methods and things like that. That's really nice for me as a non-JavaScript guy. And now I can show you that if I just say filter, for instance, and now inside of the filter method, I'm going to use a TypeScript lambda. So I'm going to say C goes to C dot, and that's the important thing. Here you see that I got the data from the web API. So I got an anonymous JSON object. But by using the interface that I created for the server world already, the filter method knows the type and is using the type for a generic method filter, and now lets me write the lambda expression with IntelliSense and types checking. And this was the point in the past when I saw demos like that where I said, that's it. Now it's time to go back to JavaScript again, to reduce the number of lines of code I write with C# and go for instance, for JavaScript and TypeScript here. So let's try it. Let's go to tsconfig and add this, where is it? Client/app.ts file here. Save it. The compiler automatically recognizes that I changed the JSON config file and immediately compiled the TypeScript file into JavaScript. And I have some very, very little code here. You see it's just a table with an ng repeat and a button which calls into my controller in the Angular 1.0 controller. And now we can say node server.js, and we can go to default HTML, and I can add some customers. You can see the foo bar that we created. We are calling into the REST web API, and we have a nice client side written in TypeScript, a server side written in TypeScript, both compiled by the compiler sitting in the background watching our files. We shared some code interfaces. We used some TypeScript type definitions to use out-of-the-box libraries, Angular and Node.js, and yeah, that's an entire small web application with a bit of background and a bit of front end. And I hope you liked it. I hope you like TypeScript. I hope you give it a chance. It's really, really nice. We use it for many, many months now. The entire team is writing TypeScript code, and we love it, especially together with some powerful backend. We are using ASP.NET, but you can use Java or Node.js or whatever. TypeScript doesn't care. So, thank you very much for listening. Thank you very much for coming. And I think we have time for 1 or 2 questions if you want. But let me say thank you for coming and open up for questions. Thank you. Any questions? Yeah. Yeah, of course. Yeah. Yeah. I have experience with System.js. It works perfectly fine with Angular 2 because you need some kind of loader for Angular 2. But to be honest, that has nothing to do with TypeScript. Well, not really. System.js, for instance, can use TypeScript as the transpiler when loading modules on the fly. So you can tell System.js to compile TypeScript to JavaScript at runtime and generate JavaScript if you want to. I would not do that because it's rather slow. So I would rather compile the TypeScript code at compile time, not at runtime, but you can. And does that answer your question a bit? Uh-huh. Yeah, you can do that. You get JavaScript. You can use any loader that is able to use JavaScript. Just System.js. We use System.js for all our Angular 2 stuff, not with the other ones. Yeah. Any other questions? Yep. Debugging that stuff, very good question. TypeScript compiler can generate source maps. Source maps can be read by any major browsers, and you can do TypeScript source level debugging. The browser will immediately pick up your map files and use them. So typically we use, for instance, gulp, and there is a gulp task where the TypeScript compiler plugs in and it generates map files. It also plays nicely with uglified JavaScript generated from TypeScript. You can still do source level debugging with all your symbols and all this stuff by using map files. Does that answer your question? Okay. Third one, and that's the last one. Mm-hmm. Yeah, the world in the module loader space, especially on the client side, is not completely sorted out. So I would really go for System.js, but I'm not sure if that my opinion will stay the same forever. The syntax was TypeScript, and try it. You have compiler switch where you can tell the system if it should spit out CommonJS JavaScript modules or AMD, asynchronous module definition files. Well, if you use something like System.js, it can handle all of them. But you have at the TypeScript compiler level the choice of these two module formats. Okay, so again, thank you for coming and have fun with TypeScript. Bye.